Now that we have a good understanding of CSF analysis, the challenges of manual cell counting, and the advantages of the GloCyte automated cell counter, let's dig into a few clinical laboratory case studies. So this first case study is going to dig into data generated at Mercy One Des Moines Medical Center. So Mercy One is a hospital located in Des Moines, Iowa. It's 600 beds. They originally came to us with a problem of physicians requesting faster CSF cell count turnaround times. So the solution was an improvement in turnaround time with GloCyte by about 16 to 30 minutes per CSF specimen, equating to a reduction in turnaround time of 122 to 128 hours annually based on a number of CSF samples processed in 2022. The benefits and impact were increased physician satisfaction and plenty of tech time freed up to complete other tasks. In fact, that equates to about a total tech time reduction of 4.4 hours a week that is now freed up to more efficiently perform other duties at the bench. The second case study will highlight a 550-bed teaching hospital in the United States who chose to be blinded on their journey to improve result accuracy with the implementation of the GloCyte. So the problem they came to us with was difficulty correlating GloCyte and the manual TNC counts during validation testing. And the solution was to do a little test. So a serial dilution experiment was performed to demonstrate that the actual GloCyte results correlated more closely with the expected GloCyte results than the actual manual results correlated with the expected manual results. So we'll get a little bit more into the details of the test that was actually done to show this, but the benefits and the impact of performing this test were increased confidence in result accuracy with GloCyte. Let's dig a little bit deeper into the serial dilution experiment. So in the table at the top, we see our expected results. First for the GloCyte TNC count method, and then the manual white blood cell count method. A CSF sample was diluted by a factor of 1 to 5 and then ran on the GloCyte to get a TNC count of 264 and counted via manual white blood cell count to get 152. And then based on those results, at the dilution factors of 1 to 10, 1 to 20, 1 to 150, and 1 to 100, the expected results were calculated. Now down here on the table where it says actual results, the CSF was then diluted by a factor of 1 to 10. It was ran on the GloCyte instrument to get a TNC count of 103, and then a manual white blood cell count was performed on the same sample, diluted 1 to 10, to get a white blood cell count of 12. This process was repeated again for a dilution factor of 1 to 20, 1 to 50, and 1 to 100. And what's interesting about these results is that the bias for the manual white blood cell count method far exceeded that of the GloCyte TNC count method. This is because GloCyte mitigates the two common types of errors associated with manual cell counting, non-random error and random error. Non-random error lies in the subjectivity of the human perspective. While one person might feel there are several cells that are outside of the grid lines and shouldn't be counted, another might think, oh, they're just barely touching, aren't they? Maybe that's good enough. Let's just count them. Random error is associated with the natural variability in the measurement process, and with 10 microliters of sample and only 1.8 microliters of sample able to be counted if the protocol is followed correctly, it isn't hard to imagine the level of random error that could be introduced in these measurements with manual cell counting. As you can see by the light purple line on the bottom, as it inches closer to the left towards 0 cells per microliter, GloCyte is able to mitigate this random error in measurement most notably in clinically relevant low-end enumerations where the determination of normal and abnormal could be hinging on a single cell per microliter. In the last case study we'll highlight as part of this deck, Boston Children's Hospital was able to improve staff satisfaction with the implementation of GloCyte. So Boston Children's Hospital is a hospital in Boston for children. It's 477 beds. The problem that they came to us with was a need for improved workflow efficiency in their laboratory for manual CSF cell counts. The solution was in these quotations. They say it's easy to operate, it's user-friendly, it provides quick and accurate results, and it doesn't take up a lot of space on the lab bench. And the benefits and impacts, clearly increase lab satisfaction and decrease stress levels. And you can't beat a 5-star review on Select Science. Thank you, Boston Children's.